Hello everyone, and welcome back to the Fluctus Channel. For more than a century, Newport News Shipbuilding, a division of HII, has been responsible for constructing every nuclear-powered aircraft carrier in the U.S. Navy. From the groundbreaking USS Enterprise, CVN-65, to the advanced Gerald R. Ford-class carriers. Situated in Newport News, Virginia, this historic shipyard covers more than 550 acres along the James River. It continues to serve as the sole designer and builder of nuclear-powered aircraft carriers for the U.S. Navy. It is also the only shipyard equipped to conduct midlife refueling and highly complex overhauls. The U.S. Navy currently operates 11 active aircraft carriers. Every one of them was constructed here at Newport News Shipbuilding. Among these, 10 belong to the Nimitz class, commissioned in 1975, while one is part of the newest class, the Gerald R. Ford class. The lead ship, USS Gerald R. Ford, CVN-78, was commissioned on July 22, 2017. Named after the 38th President of the United States, the ship honors his service to both the Navy and the nation. This massive vessel measures 2.5 football fields in length and half a football field in width, capable of supporting approximately 4,540 sailors and operating more than 75 aircraft each day. Although the hull designs of the two classes are largely similar, the Gerald R. Ford features cutting-edge technologies, including the Electromagnetic Aircraft Launch System EMLS, Advanced Arresting Gear, AAG, Ship Self-Defense System, SSDS, Dual-Band Radar, DBR, and an improved weapons handling process. Modifications to the flight deck have increased sortie generation to about 160 per day, with surge capacity reaching up to 270. The Gerald R. Ford is set to replace the Nimitz class on a one-for-one basis. At present, 2 additional Ford-class carriers are under construction at Newport News Shipbuilding: USS John F. Kennedy, CVN-79, and USS Enterprise, CVN-80. USS John F. Kennedy is expected to enter service in 2027. The ship's keel was laid on August 22, 2015, and since then, numerous major milestones have been completed. On June 22, 2017, the lower stern was installed, marking 50% completion of the superstructure. Less than a year later, In February 2018, HII announced that the ship was 75% structurally erected. In late May 2019, the bridge and island were lowered into position, and 2 months later, the final section of the flight deck was installed, completing the structural assembly of CVN-79. After structural completion, heavy systems are installed and tested to confirm reliability. Among the most critical systems on board is the new Electromagnetic Aircraft Launch System, EMALS, which is responsible for launching aircraft from the flight deck. The system was initially demonstrated through a no-load test before progressing to the dead load phase in February 2024. During this phase, a wheeled, car-like platform weighing up to 80,000 pounds simulates a real aircraft to evaluate the stress placed on the catapults during actual launches. From Kennedy's bow into the James River, the platform is launched, recovered, and relaunched repeatedly to verify that EMALS meets the operational requirements for the Navy's fixed-wing aircraft. In late October 2019, another major milestone was achieved with the flooding of the dry dock, where John F. Kennedy, CVN-79, was constructed.
3, 2, 1, go! Step away!
It was a powerful moment, celebrating the dedication of all the teams involved. Gradually, more than 100 million gallons of water filled the dock over several days. As the water level increased, the ship began to rise from the blocks that had supported it since keel laying. For the first time, USS John F. Kennedy, CVN-79 was afloat. Once fully floating, the carrier was carefully guided out of the dry dock and into the James River. 6 tugboats maneuvered the enormous vessel to Pier 3 at Newport News Shipbuilding, where it would undergo outfitting and begin its testing program. Sailors assigned to the pre-commissioning unit John F. Kennedy trained alongside their counterparts on other carriers, practicing a wide range of operations and systems prior to the ship's official entry into service. They are guided by 5 core values: integrity, humility, professionalism, teamwork, and legacy that embody the spirit of John F. Kennedy. As part of their preparation, the crew takes part in underway replenishment, UNREP exercises. During these operations, sailors work together to simulate the transfer of fuel, food, and supplies, performing complex maneuvers with supply lines, and managing critical equipment to ensure smooth and efficient coordination between vessels. In addition to carrier operations, Newport News Shipbuilding plays a crucial role in supporting other vital fleet assets such as destroyers. Built for speed, maneuverability, and firepower, destroyers represent a powerful striking force within the Navy fleet. Maintaining operational readiness is essential to fulfill their mission of protecting major ships like carriers. As a result, crews perform routine maintenance every day to keep the ships at peak performance. Essential tasks include lubricating mechanical systems, replacing worn components, and conducting corrosion control to withstand harsh maritime conditions. Every system is carefully inspected to preserve combat effectiveness.
Maybe they mean that when we're actually.
For more extensive maintenance, destroyers are placed in dry dock for phase maintenance or damage repairs. One notable case is the Arleigh Burke-class guided missile destroyer USS Fitzgerald, DDG-62. In 2017, the ship entered dry dock, following a collision with the merchant vessel ACX Crystal. To rapidly stabilize the ship, USS Fitzgerald was towed to the ship repair facility in Yokosuka, where technicians and shipbuilders made significant progress in dewatering, defueling, completing hull and superstructure repairs, and placing essential systems into layup maintenance. USS Fitzgerald was later moved from the dry dock to a pierside location in preparation for transport to Huntington Ingalls Industries, HII, for further repairs and upgrades. At the HII shipyard, Fitzgerald underwent both repair and new construction processes to achieve full restoration and modernization. Numerous components required replacement, while others needed partial or complete refurbishment. This work included hull mechanical and electrical systems, along with command, control, communications, computers, and intelligence and combat system equipment. Critical systems addressed included the electronic warfare suite, radar, switchboard, gas turbine generator, and air conditioning plant. After 2 years of restoration and modernization, USS Fitzgerald returned to the fleet stronger than ever, ensuring an extended service life. Like surface ships, submarines also undergo regular dry docking to remain mission ready. To start the process, the submarine arrives at the port under its own power. Tugboats then assist by providing lateral control and ensuring a precise approach to the assigned dock. As the submarine nears the dock, a crew member swings the weighted end of the heaving line and throws it toward the quayside operators. The added weight allows the line to travel farther, enabling shore personnel to catch it. Once secured, the shore crew pulls in the heaving line and loops the mooring line around the bollard. The submarine crew carefully adjusts line tension to maintain a stable position alongside the quay. Additional lines are passed and secured to prevent any movement. When it is time for dry docking, the submarine is unmoored and transferred into the dry dock. Throughout this operation, the submarine's commanding officer and navigator coordinate closely with harbor pilots, who possess detailed knowledge of the port to ensure safe execution. Step by step, the submarine is carefully maneuvered into the dock. At the platform entrance, tugboats disengage and crew members assume control. From both sides of the dry dock, multiple mooring lines are continuously adjusted to keep the submarine centered and prevent contact with the dock walls. Once aligned, the dock is gradually drained, and the submarine settles onto keel blocks shaped to match the hull. With the submarine secured, crews can easily access the hull, inspect vital systems, and begin required repairs and upgrades. After months of maintenance, the submarine is ready to undock. The dry docking process is reversed as water is pumped back into the dock, and the submarine gradually regains buoyancy. Once afloat, personnel along the sides monitor its position before tugboats take control and guide it back to the pier. Only one step remains before returning to operations: sea trials, where comprehensive tests ensure all systems function properly after maintenance. From the towering flight decks of nuclear-powered aircraft carriers to the precise dry docking of destroyers and submarines, Newport News Shipbuilding remains central to the United States Navy's ability to project power, sustain operations, and adapt to future challenges. Whether it is the next-generation Gerald R. Ford-class carrier preparing to launch aircraft with EMALS, a battle-damaged destroyer restored and modernized for decades of continued service, or a submarine carefully returned to the sea after months of detailed maintenance, the work never truly ends. This continuous cycle of construction, overhaul, testing, and training is what keeps the fleet ready today and credible tomorrow. Newport News Shipbuilding is more than a shipyard. It is a living connection between American industrial strength and naval dominance, ensuring that when the fleet sails, it does so with confidence, reliability, and unmatched capability. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.